Hi students, hope you are doing well. Today we are going to start the stability and control part of this course, and we are going to start with some of the fundamentals in terms of the aircraft control surfaces and the different motions you can generate by moving these control surfaces. This is lecture 50 of the course. I am Dr. Ranjan Ganguly. So we have seen here that when we had the situation of aircraft performance, for example, consider our previous lecture in terms of accelerated rate of climb, we had the system essentially governed by translational forces. So you can see here the forces T, D, L, W. These are all translational forces, and we were able to get a lot of things done. We developed a lot of mathematical models through these forces. But what's going to happen now is that we are going to have to start looking at moments which are acting on the aircraft if we are planning to control it. So the moments are going to become important. So in aircraft stability and control, the problem is largely governed by moments. And what happens is that through these moments, you can control the aircraft in the different directions. So to start thinking, let's start with this aircraft, and we know that the center of gravity is some point here, which I have made in the blue dot. Now, from this point, we can draw three different axes. So the coordinate system is X, Y, and Z respectively, which I have shown here. Now let's look at these directions and look at some of the things which act along these directions. So in the direction X, there is a velocity U. In the direction Y, there is a velocity V. In the direction Z, there is the velocity W. Now this X corresponds to the roll direction. So what happens here is that there is an angular velocity P and a moment L dash which is associated with this direction X, and this is essentially the rolling moment L dash and the roll rate P. Now we use this direction or this particular moment to do what is known as lateral control. So lateral control involves roll, and it's along the X direction here. Now if we look at the Y direction, this is the direction of longitudinal control, and here the moment M is a pitching moment and Q is the pitch rate. So all these rates are in terms of angular velocity and the moments are in terms of Newton meter. Now if we look at the Z direction here, we can see here that you have the yaw moment N and the yaw rate R, and again this particular axis Z, it corresponds to directional control. So essentially through these three axes we can use roll control, we can use pitch control, and we can use yaw control. Also correspondingly the words lateral control, longitudinal control, and directional control are used. So you can familiarize yourself with this particular nomenclature by taking a good look at this particular diagram and essentially memorizing all the different aspects here. Now the yaw control is something which is easy to remember, but it's important to remember that longitudinal control is in the y direction and lateral control is actually in the x direction. So now if we look at the three different velocities u, v and w, we can clearly see that the resultant velocity is given by v infinity, and that is the square root of u square plus v square plus w square. Also, like I mentioned before, the CG is the center of gravity. This is the point through which the entire airplane weight acts. This is often an assumption which is made in rigid body dynamics. Now let's again summarize some of these things because they are so important. Like I mentioned here, P is the roll rate and L dash is the rolling moment. These are associated with the X direction. Q is the pitch rate and M is the pitching moment. These are associated with the Y direction, and R is the yaw rate and N is the yawing moment. These are associated with the Z direction. Also, if you look at any aircraft, we of course have the wing. This is the source of lift which is required for the aircraft to fly in air. But we also will typically see a horizontal tail and a vertical tail. So these surfaces are actually required for stability. We are going to discuss that in more detail later in this particular part of the course. Sometimes these are also known as the vertical stabilizer and the horizontal stabilizer. So essentially you will see here some analogy with fish and bird type of systems. So now we are going to discuss the three control surfaces which are very important for aircraft control. So let's start with the ailerons, which are the control surfaces required for roll control, and I have shown these kind of surfaces here in the yellow. So these are surfaces which are similar to trailing edge flaps, and the pilot can move this up or down, and what this helps to do is can help you to increase the lift or to decrease the lift. So if you move it up, the lift will decrease. If you move it down, the lift will increase. So let's take a side view, or rather a front view of this aircraft. And if you look at it from the front, you can see if the aileron is put down on this side, the lift will go up. If it's put up on this side, the lift will go down. And so the net result will be a rolling moment will be developed, and this is the rolling moment L dash. So essentially the two control surfaces here are moved in a differential manner. So one goes down, one goes up, and the result is that a rolling moment is created, and this can be used for lateral control of the aircraft. So remember always rolling moment is related to lateral motion, and the ailerons are the control surface which are used for lateral control. Now let's look at the next control surface, which is known as the elevator, and these are situated on the horizontal tail or the horizontal stabilizer. So I have again shown these in yellow here. So these are also devices which are similar to trailing edge flaps. Now if we take a look at a typical aircraft, so I am looking at this aircraft from behind. I can see here if both these are put down, then the lift will go up. So do remember these are like trailing edge flap devices. So if I bring them down, essentially it changes the camber of this particular wing section, and so the lift goes up, and therefore what's going to happen is that there is going to be a moment which is going to develop, which is going to put the nose of this aircraft down. So that's essentially pitching the aircraft, and so elevators are used for pitch control. Now you can see this more clearly in this diagram, which is a side view. So here the way I have shown it here is that this small control surface here is down, and therefore there is a lift which is going up, and so the moment M is developing here, which is the pitching moment. So by doing this, essentially you can pitch the aircraft, and so you can control the longitudinal direction, you can generate longitudinal motion, and therefore these control surfaces are used for longitudinal control. Now let's take a look at the third control surface, which is the rudder, and the rudder is situated here. I have again shown it in yellow. It's in the vertical tail. So again this can be moved in the leftward direction or the rightward direction, on depending on that particular forces can be generated on this control surface. So what happens here is that if I take a view from behind here, I can see I can deflect this in one direction here, and so what would happen is that there would be a force generated in this direction, and then because of this force there would actually be a yawing moment which would be developed about the CG. So again this kind of rudder is used for directional motion and directional control, and that is related to the yawing motion. So if you are somebody who has ever tried to navigate a boat, you will always know that there is a rudder there even in simple paddle boats, and so that's one control surface we are pretty familiar with. So to summarize, we see today that three very important control surfaces are there in the aircraft through which the pilot can control the vehicle. Essentially these are the ailerons, which are used for lateral control, the elevators, which are used for longitudinal control, and rudder is used for directional control. So let us summarize today's lecture, which essentially started our journey into the stability and control aspect of aerospace engineering. We see that control involves moments and rotations. So these are things which are somewhat different from what we were doing in performance. In performance, we were looking at translational forces most of the time. Now we are going to look at moments. Now, we also saw that there are these control surfaces which essentially create rolling, pitching, and yawing moments. So these three moments are essentially used to control the aircraft, and also these are related to lateral, longitudinal, and directional control. So these are the three axes along which you can control the aircraft. So these three control surfaces allow you to control the aircraft in three directions, and therefore the pilot has complete control on the aircraft through these control surfaces. Now, we also just mentioned in passing about the importance of the tail. So the tails are something which play an important role in aircraft stability. So we are going to discuss that later in the course. And in the next lecture, I'm going to start the discussion about stability. We are going to discuss about static stability and about dynamic stability. And later in the course, it will become clear to you why the horizontal tail and the vertical tail, or the stabilizer as they are sometimes known as, are important in terms of stability. So essentially, control is a very important part of any aircraft. You will now see that in addition to performance, one of the things, of course, which is required is that you should be able to control the flight vehicle in flight, and different levels of control and stability are required based on the aircraft system you are dealing with. If you are dealing with a transport, these things should be done smoothly and so on. It should be a more stable system. If you are dealing with a combat aircraft, essentially it's somewhat of an unstable system. So you should be able to get good maneuver capability and so on. So some of the requirements are of course different, but we will see that most aircrafts we see out there, the fundamental makeup of the aircraft remains same. We still see that aircraft have wings and the aircraft have horizontal and vertical tails. So these are very important configurations which have remained more or less true in most aircraft. Sometimes you will see the tail is behind, sometimes the tail may even go in front. That's known as a canard. So those are situations which are possible, but then again the tails are something which are very important in aircraft. So I'll end this lecture now. I will see you in my next video when we'll talk about stability.